We're not completely sure if the universe is infinite just yet, but from how little we currently know about the cosmos, it's more than justified to say that it is. With that said, you'd be pretty sure there are a bunch of strange planets out there, innumerable to say the least. If you've imagined it, it probably exists somewhere in the bounds of the universe. NASA has been hard at work peering into the great beyond, looking for these planets, some of which have been baffling the greatest minds. How can a planet be made out of diamonds? What are blanets? And have we really found hell in our universe? Let's find out. If you've ever imagined what it would be like to just wake up one day and find out that you have an unlimited supply of gemstones, this planet has that and more. Also, you'd be pretty sick of gemstones if you lived there. Meet exoplanet HAT P7b, a world 40% larger than Jupiter, orbiting a star 50% more massive than our Sun, and some 1,040 light-years away. Astronomers at the University of Warwick in Coventry, England, announced they've detected evidence of powerful changing winds sweeping across this giant exoplanet HAT P7b in 2016. They reckoned that their findings were the first ever weather reports on a gas giant outside of our solar system. And I gotta tell you, that is some weather right there. They report that the planet's clouds could be made of vaporized corundum, the mineral that forms rubies and sapphires. If we could view the planet's clouds, it would be nothing short of stunning. David Armstrong of Warwick's Astrophysics Group led the research. He said that the strong winds moving across HAT P7b likely lead to catastrophic storms. Armstrong and his colleagues researched this using data from NASA's planet-finding Kepler satellite. They monitored light being reflected from the atmosphere of HAT P7b. This exoworld is so close to its star that its day side is a searing 3,500 degrees Fahrenheit. That's over 1,900 degrees Celsius. This world, specifically an equator, has dramatically variable wind speeds at their fastest, pushing vast amounts of cloud across the planet. HAT P7b is a tidally locked planet, with the same side always facing its star. Clouds are expected to form on the cold night side of the planet, but they would evaporate quickly on the hot day side. This means that strong winds circle the planet, transporting clouds from the night side to the day side. The winds change speed dramatically, leading to huge cloud formations building up then dying away. Here's what we currently know. Giant exoplanet HAT P7b has clouds made of the mineral that forms rubies and sapphires. But some planets are as pleasant. Traveling 65 light-years away from Earth, you might come across a pristine blue marble of a planet that seems like an exotic vacation destination. The planet, quaintly named HD 189733, is a gas giant that completes an orbit of its star in just 2.2 days. Looks, though, can more often than not be deceiving. The exoplanet has a pristine blue hue because of its fatal weather conditions, most notably its molten glass rains that hit the planet's surface ever so often. If you thought that was strange enough, this actually isn't the only thing that makes its weather conditions deadly. Discovered in 2005, this exoplanet experiences winds of around 5,600 miles, that's 9,000 kilometers, per hour. These crazy winds cause the planet's glass rains to arc sideways to the ground instead of just falling straight. The rains pick up silicate particles, turning them into microscopic projectiles. Getting a puncture wound on this planet is the least of your concerns. HD 189733b has piqued the interest of astronomers for other reasons as well. The giant planet has an atmosphere that is much larger than scientists would intend for a planet with its characteristics. This extended atmosphere catches more of the already considerable amount of radiation the planet receives from its star, thanks to its incredibly close orbit. giving it temperatures as high as 1,700 degrees Fahrenheit or 930 degrees Celsius. Since the atmosphere is capturing so much intense radiation, the HD 189733 binary system, which includes the planet and the star, are rapidly being stripped away to space. Scientists are not too sure what this might result in, and honestly, I think we should just observe it from a distance for now. 40 light-years away from our solar system in the Zodiac constellation lies 55 Cancri E. For those of you who didn't read the title, this planet is made up of carbon, principally as diamonds and graphite. Your ears aren't deceiving you, young Padawan. Taking just under 18 hours to complete an orbit around its star, 55 Cancri E is hot, and like really, really hot, reaching scorching temperatures as high as 4,172 degrees Fahrenheit or 2,300 degrees Celsius. Professionally called Janssen, its composition makes this exoplanet probably the most valuable object in the universe, at least for us human beings. 55 Cancri E is twice the size of Earth, but has almost 9 times the mass. This led astronomers to propose that this super-Earth exoplanet could be composed of high-pressurized carbon in the form of graphite and diamond mixed with some iron and other elements. We did some digging and figured out that the planet is worth 384 quadrillion times more than Earth's entire gross domestic product, or GDP, valued at $70 in 2011. We're pretty sure it's way more right now. Several astrophysicists think diamond worlds like this are plentiful, since the formation of these planets is a fairly common process, and considering how much we don't know about the universe, there might be millions of similar planets like this one. Not all exoplanets need to form around stars. They could instead orbit supermassive black holes. In theory, that is, planets form from the gravitational collapse of overdense areas with protoplanetary clouds of gas or dust, and supermassive black holes at the heart of active galactic nuclei of AGN sit at the center of massive churning out disks of the same stuff. Although we don't really have any evidence that such black hole orbiting planets, or blanets, actually exist, recent research concerning the dynamics of these disks of gas and dust does suggest that under certain conditions, planet formation should happen in places like these. If this is true, blanets would form much further out from the supermassive black holes than most planets do from their parent star. They could be orbiting so far away that it could take 1 million years for such a world to complete an orbit. The AGN's radiation could help provide a constant supply of fresh material for planet formation, which could result in runaway formation, meaning planets could reach sizes far greater than regular exoplanets. Planets wouldn't share similarities to Earth or Jupiter, which means there would be whole new classes of astronomical objects beyond gas giants and terrestrial worlds to investigate. In late 2019, NASA's Transiting Exoplanet Survey satellite first detected TOI 1431b. Astrophysicist Dr. Brett Addison carried forward several follow-up observations with a team of astronomers using a Stellar Observation Network Group telescope in the Canary Islands, along with other telescopes across the globe, just to make sure this crazy exoplanet existed. Also known as Mascara 5b, TOI 1431b sits 490 light-years from Earth. The gaseous ball of flames is one of the hottest planets ever surveyed. It has been dubbed ultra-hot Jupiter, though it's nearly twice as large as our neighborhood giant, which is the solar system's largest planet. Addison, the lead researcher of the study, said in a press statement, "This is a very hellish world. Dayside temperatures of about 3000 K or Kelvin, that's approximately 2700 degrees Celsius, and nightside temperatures approaching 2600 K or approximately 2300 Celsius. no life could survive in its atmosphere. In fact, the planet's nightside temperature is the second hottest ever measured. To put that in perspective, the temperature of molten lava typically falls between 970 K or approximately 700 degrees Celsius to 1520 K or approximately 1250 degrees Celsius. So the planet is literally far hotter than hot liquid rock and greater than the melting point of most metals, many of which turn to liquid under 2273 K or 2000 degrees Celsius. The planet's blistering temperatures are approaching that of a rocket engine exhaust. This could most definitely be hell in our universe. So, what other exoplanets have intrigued you? Could blanets really exist? And what other strange worlds are we going to find? Let us know in the comments, and as always, thanks for watching Space Age.